Have you ever really stopped to think about what makes the internet, well, work? Every single time you browse a website, send an email, or download a file, you're relying on a set of invisible rules. Well, in this explainer, we're going to pull back the curtain on the four foundational protocols that are the absolute bedrock of our digital world: HTTP, FTP, SMTP, and DNS.
So here's the game plan. We'll kick things off with the application layer. That's kind of the neighborhood where all these protocols live. Then we'll get into the big four, one by one: HTTP, which is all about web browsing; FTP, for moving files; SMTP, the engine behind email; and DNS, the internet's phone book. And then we'll tie it all together to see how these four pillars hold everything up. All right, let's start at the very top. To really get what these protocols do, we first have to know where they operate. So, welcome to the application layer. It's the highest level in the internet's rulebook, the TCP/IP model. You can just think of it as the part of the network that you, the user, actually see and interact with every single day. So what's its job? Think of the application layer as a master translator and concierge for all your software. It's the layer that lets your web browser, your email app, and pretty much everything else speak the language of the network. It sets the rules for how data is supposed to be packaged, sent, and understood, so everyone's on the same page. Okay, first up, HTTP, the Hypertext Transfer Protocol. If the internet is this giant, endless library, then HTTP is the tireless librarian who fetches every single web page for you. It's the engine that makes the World Wide Web roar to life. Now, here's the key. HTTP runs on a really simple but powerful model: request, response. Your browser asks for something, and a server gives something back. And see that word, stateless? That's huge. It means every request is a fresh start. The server doesn't remember who you are from one click to the next. That design made the web simple and scalable, but it also created challenges that things like cookies were invented to solve. And here is that request-response cycle in action. It's a four-step dance that happens in the blink of an eye. Your browser, the client, sends a request, something like "get me the home page." The server grabs the files, works its magic, and sends back a response package with the content and a little status update. And finally, your browser pieces it all together into the web page you see. Right, and that little status update is a code. You've definitely seen these before, even if you didn't know what they were. A 200 is perfect. It means, okay, here's what you asked for. A 301 or 302 just means, hey, that thing you wanted has moved over here. And then, of course, there's the infamous 404 not found, the internet's dead end, or a 500, which means something broke on the server side. Now, this is absolutely critical. You know that little lock icon in your browser? That's the S in HTTPS, and it stands for secure. See, regular HTTP sends data out in the open, like a postcard anyone can read. But HTTPS wraps everything in a layer of encryption using something called TLS. This is what protects your passwords and your credit card info. It's literally the difference between sending a postcard and sending a sealed armored truck.
So why is HTTP such a big deal? Because it's not just for websites anymore. It's the backbone for APIs that let all our different apps talk to each other, and it's what feeds the content into the mobile apps you use every day. HTTP is what turned the internet from a bunch of static documents into the dynamic, interactive world we live in today. All right, next up we have one of the true originals of the internet, FTP, the File Transfer Protocol. Long before we were binge-watching shows and scrolling through social media, we just needed a solid, reliable way to move files from one computer to another. And for that, FTP was the answer. At its heart, FTP is just beautifully straightforward. It was built for one job: transferring files. That means uploading things to a server, downloading things from a server, and managing the folders on that server. It really is the internet's dedicated courier service. But here's what makes FTP so unique. It uses this cool dual-channel system. It separates the conversation from the delivery. The control channel handles all the commands. Log me in, list the files, I want to download this. Once the order is placed, the data channel opens up and does all the heavy lifting of actually moving the file. It's a surprisingly efficient design. But just like with HTTP, security is a big deal. Plain old FTP sends everything, including your password, unencrypted. That's why today we pretty much always use its secure cousins. FTPS basically wraps FTP in the same kind of encryption that HTTPS uses. SFTP, on the other hand, is a totally different animal. It's not even based on FTP.
It runs over the Secure Shell Protocol, SSH, giving it rock-solid security from the ground up.
Okay, time for our third protocol, and this one is all about communication. Let's talk about SMTP, the Simple Mail Transfer Protocol. If you've ever sent an email, you've used it. It is, quite literally, the global postal service of the internet, making sure your messages get where they're going.
So the most important thing to get about SMTP is that it's a push protocol. Its job is to send and relay mail. When you hit send, your email client pushes the message to a mail server using SMTP. It doesn't handle receiving mail, though. That's for other protocols like POP3 or IMAP, which pull the mail from the server down to your inbox.
And this just lays out that whole journey. So you send a message. Your email client shoots it over to your outgoing mail server. That server then acts like a post office, looking up the address and forwarding your message along a chain of other SMTP servers or relays until it finally lands at the recipient's mail server. Only then can they use something like IMAP to download it and read it.
Now, like any network service, SMTP uses specific digital ports. You could think of them as numbered doors on a server. Port 25 is the classic, but it's totally unsecured. These days, for secure email, we rely on ports like 465 for SMTPS, or, more often, port 587, which encrypts the connection. Using these secure ports is absolutely essential for keeping our emails private. And that brings us to our final protocol, and honestly, it's the one that makes the entire internet user-friendly. I'm talking about DNS, the Domain Name System. Without it, browsing the web would be an absolute nightmare. It's the directory service that connects the names we remember to the numbers computers need.
Yeah, this phone book analogy is perfect. It's the one everyone uses because it just makes sense. We humans remember names, like Google.com, but computers, they only talk in numbers, these IP addresses like 142.250.190.78. DNS is the massive global phone book that looks up the name you type in and finds the right number so your computer can connect. I mean, really think about that for a second. You type a domain name into your browser, hit enter, and bam, in a fraction of a second, the right website appears. Out of billions of websites, how does it know exactly where to go? Well, the answer is this really clever, lightning-fast process called a DNS lookup. This lookup is like a high-speed scavenger hunt. First, your computer asks a local DNS resolver for the IP address. If it doesn't know, it starts climbing the ladder. It asks the main root servers, hey, where do I find info for .com? They point it to the .com top-level domain servers. It asks them, okay, where do I find example.com? And they finally point it to the authoritative server that holds the actual IP address, which then gets sent all the way back to your browser.
And that phone book has all different kinds of entries, which we call records. An A record is the most common. It just maps a name to an IP address. A quad A record, or AAA, does the same thing for the newer IPv6. But you've got others, like an MX record, which is what tells SMTP where to deliver email for a domain. It's a really versatile system. So let's bring this all home. We've talked about 4 separate protocols, but the magic is that they don't work alone. They are truly the 4 pillars of the application layer. You know, when you click a link in an email you received via SMTP, it's DNS that finds the server, and it's HTTP that fetches the web page. They are constantly working together, forming the foundation of basically everything we do online.
You see, understanding these protocols, HTTP for browsing, FTP for files, SMTP for mail, and DNS for addresses, it's more than just a tech lesson. It's about learning the fundamental language of the internet itself. And that leaves us with one last question. Now that we know the rules of the game, how can we use that knowledge to build a web that's not just more powerful, but also safer and more private for everyone? That's the real challenge ahead. Thanks for diving in with me.